Hello everyone, welcome to Project 1, the marble roll problem of Dr. Bowers. In this video, I'll guide you through all the questions that may help you complete the project. First, we'll talk about the hypothesis table. In this table, try to form your own hypothesis about the motion of the objects, such as would it increase, decrease, or have a constant speed as the object is rolling down the plank. In this table, you will find there are 4 graphs. These graphs hypothesize the motion of the object as it's rolling down the plank. For example, in graph B, the object after 0.5 seconds is rolling down 2.5 feet. After 1 second, the object is rolling down 4.5 feet. You will need to decide which graph accurately represents the motion of the object. For the incorrect graphs, you need to explain why they are incorrect. The materials and instruction for the experiment can be found in another video on Blackboard. Next, you need to fill in the provided table the times it takes for the object to roll down the plank. For example, in my table, trial number 1 takes 0.337 seconds to roll down 1 foot, and trial 2 takes 0.220 seconds. Trial 3 takes 0.277 seconds. In order to find the average times, you need to add all these 3 times together and divide by 3. As a result, my number is 0.834 seconds. Repeat the same calculation for the object rolling down at 2 feet, 3 feet, and 4 feet. Suppose in my experiment, the result comes out to be 1.3, 1.5, and 1.6 seconds. In question 1, you are asked to plot the graph of distance traveled versus average times. To do this, we first open Microsoft Excel and type in all the data. Notice that you have to put the average times column on the left of the distance traveled column because you want your x-axis to be the average times and your y-axis to be the distance traveled. Otherwise, it will flip the x and the y-axis. Also notice that we have to start at 0, 0 because that is the origin. After that, we select all the data, go to Insert, Scatter, and select Scatter with smooth lines and markers. When you're done, right-click on the graph, choose Copy, and then paste it on your Word document. Question 2 asks you to compare your result with the 4 graphs above in the hypothesis table. Confirm and explain if your hypothesis is correct. Otherwise, explain why the outcome is different. In question 3, we need to find the value for A using the formula distance equal A times by t squared. Recall that the average time required for the object to roll 1 foot is 0.834 seconds. Therefore, the value for A is distance divided by t squared equal 1 divided by 0.834 squared, and the result is 1.438 feet per second squared. Repeat the same calculation for 2, 3, and 4 feet. In order to find the average value for A, you need to add all the value for A and then divide by 4. In my example, the result is 1.379 feet per second squared. You are also required to graph the function y equal ax squared. Recall that the value for A is 1.379. Therefore, the function y is y equal 1.379 times by x squared. To graph this function on Excel, first open Excel and copy the average time column. Ctrl C may be the fastest way, and then Ctrl V to paste it. On the right side of the average time column, create another column and name it y equal a times by x squared. The first value is 0. In this box here, in the function box, type in equal. Because the value for A is 1.379, so we have 1.379 multiplied by this value here and squared. So this is gonna be the result of the function y equal 1.379 multiplied by the time squared. Drag your mouse to the corner until you have a plus sign like this, and then drag it down to the very last number to create a table. In order to graph this table, first right click on the graph Select data, add it. The series name, let's name it y equal a x squared. The x value is the average time travel, so let's select this column. The y value is the function y, so select this column. Click OK. OK again. In question 5, you are asked to calculate the average speed of the object rolling down the entire trip. To do this, you have to take the total distance traveled divided by the total time traveled. Recall that in my experiment, it required 1.6 seconds to travel 4 feet. Therefore, the average speed is 4 divided by 1.6, and the result is 2.5 feet per second. In part B, you need to draw a line from the origin to the last distance being measured. In order to do this, go back to your Excel, go to Insert, click on Shapes, and choose the line right here. Click on the point and hold the left mouse. Do not release it. Drag it to the last point, and that will create your line. You can right click on this line, format shapes, and make it a little bigger. Easier to see that. You can even change the color if you want. After this, you need to calculate the slope of this line. In question 3, you are asked to draw a straight line tangent to the curve at x equals 1 second. To do this, go back to your Excel. If you want, you can make it a little bit bigger. Our focus will be the red line. After 1 second, the object is about 1.3 feet. To draw a tangent line, first go to Insert, Shapes, choose Line, and then draw a tangent line. You can use the end point here to rotate it, to move around the tangent line until you see that fit. Repeat the same process for part B.